Welcome to qnawire.
Okay, of the two, cesium-140 and cesium-133, if we use the figure 24.2, it'll help us identify the region where we have stable isotopes. If we look at cesium-140, it has a neutron to proton ratio of 1.55. And if we look at the table, there is no stable isotope with an atomic mass of 55 having a neutron to proton ratio of 1.55. So this one's got too many neutrons. It's too heavy. It's likely to undergo beta emission. While this one, the neutron to proton ratio brings it closer to that zone of stability. So this would be the stable one, and this other one has too many neutrons. Then for the next one, we've got bromine-79, which has a neutron to proton ratio of 1.26. And then we've got bromine-78, which has a neutron to proton ratio of about 1.23. So the neutron to proton ratio is not as helpful for bromine in this case, because they are very close to each other. So in order to figure out which one is more stable, we simply need to look at other things, such as even number of protons, even number of neutrons, look at to see whether or not there are any magic numbers that are present. There are no magic numbers that are present in either one of these. But what we can see is the first one has an even number of neutrons, while the second one has an odd number of neutrons and an odd number of protons. And there are very few stable isotopes that have an odd number of both protons and neutrons. So this one is likely unstable, while this other one that has an even number of neutrons is the stable isotope. Then we look at magnesium-28. It has a neutron to proton ratio of 1.33, which seems a little high for a pretty light nucleus. And when we look at table 24.2, it is. And then magnesium-24 that has a neutron to proton ratio of 1. So this first one, which has a high neutron to proton ratio, is unstable because it has too many neutrons, while magnesium-24 is the stable isotope. Then for the last one, we have nitrogen-14, which has a neutron to proton ratio of 1. And we look at nitrogen-18, which has a neutron to proton ratio of 1.57. Again, you look at table 24.2, and you see the atomic number of 7, and there is really no stable isotope that has any more than 10 neutrons when we have 8 protons. So we go down to 7 protons. There's really nothing stable that has more than maybe 8 neutrons. So the fact that we have 11 neutrons with nitrogen-18 suggests that this is very unstable, and nitrogen-14 is the stable isotope of the pair.